In this video, I'm going to go through solving compound inequalities, and specifically the compound inequalities that deal with the word and. Those are sometimes referred to as conjunctions. So I have an example here. I want us to solve this inequality, and then when I'm all done solving it, notice I want to put in set builder notation. Now when you have a compound inequality that looks like this, the first thing to determine is this an and or is this an or inequality? Now if we remember back to other compound inequalities that we solved in the past, when we see that we have something and then less than something else, less than, or in this case less than or equal to another item, we are dealing with an and or a conjunction. So what we want to do then is we want to take this and we want to break it into two inequalities like I have noted up above. And those two inequalities that we're gonna find are this one here to the left, and then we're going to have the one to the right. And notice both of these inequalities share the middle part of this. So I'm just going to rewrite it as 1 minus 7x less than 3 minus 8x. And then I'm going to go through and I'm going to solve that inequality. My other one, like I said, is 3 minus 8x is less than or equal to 5x minus 10. So I have these two inequalities to go through and solve. So my first one here, I'm going to add 8x to both sides. And I'm also I'm gonna do two steps in once. Notice I'm getting all the x variables to the left side, which means I have to have all the constants to the right side. And if I have to have the constants to the right side, this one has to go away. So I'm going to subtract 1 from both sides as well. And when I do that, I end up with x is less than 2. And my first inequality is solved. Then I can go on to my second inequality. So on this one, I'm going to get all my x's to the left again. So that means I'm going to have to subtract 5 x's from both sides. I'm going to get all my constants to the right side, so I'll have to subtract 3 from both sides. Now my inequality says negative 13x is less than or equal to negative 13. I go this additional step, and I divide both sides by negative 13 to get the x all by itself. Now remember, when we divide by a negative in an inequality, we have to flip the sign. So now it looks like this. So I have these two inequalities now, and I want to cram them back together into the compound inequality. Remember, we had an and compound inequality. So we can write it very similar to how it started, but then I also want it in set builder notation. So when everything's all said and done, set builder notation, remember, squiggly little parenthesis, our variable, such that, and now we come into our inequality. And if it's an and inequality, we always want to start with the smaller number. So in this case, it's the 1. So 1, now the 1, if we read it backwards, is less than or equal to our variable x. So it doesn't matter if we have it written like we see it here or up here. You know, most of the time I think my variable x is greater than or equal to 1. So if I read this one backwards, x is greater than or equal to 1. Now I have to go to my green inequality and incorporate that into my set builder notation. Well, that says x is less than 2. So I come down here, I already have the x now is less than 2. And then close my parenthesis. And I have solved that original compound inequality from right there. Remember, broke it into two parts, and then I wrote my solution set in set builder notation. Now, on this one, I just want to graph the solution set to this compound inequality. Now, this is the same one that we just solved on the previous page, so I'm just going to pull our solution, which we had right here. Notice it doesn't look any different than what it is there, other than this one's a little more colorful. And now I just have to graph it. Remember, and compound inequality, that's the one that's going to look like we have the two endpoints, and then everything in between is a solution, or that's the part that's shaded. So then we got to focus on our endpoints, which are at 1, and we want to include 1 in our solution because it has to be less than, or x is less than or equal to 1. And then we also have the 2. Now that one, notice we don't include because x is less than that, and then we're going to have everything in between it. So there we go. So our solutions are all of those numbers in between 1 and 2. Don't include the 2, but do include the 1. Then I have one more here. I thought we'd try a second one. And again, we're not going to solve it really any different. We're going to break it into its two parts. We're going to take a look at that inequality. We're going to solve that one. And then we're going to take this one and solve this one. So I'm going to start with the red one. 4x minus 10 is less than negative 8 plus 3x. I'm going to get all my variables to the left side. And I'm going to get all my constants to the right side. Now, if you like to take this and solve it as two steps, that's just fine. So now we have x is less than 2. I'm going to go to what I circled in blue. Negative 8 plus 3x is less than 5x plus 2. And I'm going to solve this one. So on this one, I'm going to subtract the 5x from both sides. I'm also going to add the 8 to both sides. Now we have negative 2x less than 10. I have to solve or divide by negative 2. Now I have x here. I'd have negative 5. And again, remember, when we divide by negative, we have to flip the sign. Now, to write that into set builder notation, squiggly parenthesis, our variable, such that, and remember, start with the smaller number. And in this case, the smaller number is the negative 5. So we have negative 5 is less than our x. Now we go to the second inequality, which says x is less than 2. So x is less than 2. And then finish that out with our squiggly parenthesis. So again, we have a and compound inequality here. And we have all those solutions in between negative 5 and positive 2. And then again, on this one, I wanted to graph that solution set. We already have it. So we just have to focus on negative 5. Color guys, so I'm going to go back here. We have the negative 5 will be our purple. And do not include all the way up to positive 2. Don't include that one either. And then we're going to include all of those solutions in between. And that is going to conclude my lesson on solving compound inequalities, specifically the conjunctions, the one that use the word and.